Alright, so we're going to talk about clock math and check digits. So we're just going to do the clock math part today actually. First of all, motivating example. Say we have a secret meeting in 50 hours. It's 2100 military time now, which translates it as 9 p.m. What time do we meet our contact? So, the long way to do this, and this is not how we're going to do this, but military time, first of all, you guys know how to go from PM, AM, PM to military time. So we say 2100 and then so we don't have to use any colons there, and it's just a way that is easier to say and write. And then, so 9 p.m., we just take the 2100 and we subtract 12 if it's greater than 12, and that gets us 9. And so, or 900, so the 00 part is just like the minutes part. So anyway, if we are meeting our contact in 50 hours and it's 2100 military time, I'm just going to shorten the 100 part and say, well, it's 21 hours, 2100, just the 21. So if I counted, it'd be 3 hours left in the day, the present day, and then we're going to go through a whole entire cycle of 24 hours for the next day, and I'm still not going to be at 50. And then I'm going to have to go into the day after that, and I'm going to get up to 2300 hours, and that's when you're meeting the contact if you count up 50 hours. So this isn't the best way to do this problem, and certainly if we're meeting our contact in, I don't know, 500 hours, this would not be something we want to go through, counting all those cycles at 24. So we're going to try to put this in a way that we can do this a little bit more efficiently. So here's a shortcut. Notice that we went through several cycles of 24 hours. Look at your formula sheet. And the formulas aren't in order here. We're in military time, which is the third section down in the front. And so here the formula says future military time is equal to the present military time plus the number of hours times 100 in brackets mod 2400. Mod 2400, what does that mean? So the mod 2400 means where are you in the cycle of 2400 hours? So the clock here is, in military time, is on a 2400 time period before it starts over. So for our problem, the present military time is 2100, and then we had 50 hours, which is not in the same kind of scale. So 2100, the 21 is the hours part, we got to make that agree. So you do that by taking 100 times the 50, so then their place values line up. So 100 hours is how much we got to add. We do that addition, we get 7100, and now what we want to see here is combined in there are a couple days, and so you want to take that part out. The mod 2400 is the directions that say, well, take out the cycles of 2400. So a shortcut is to just do long division and look for the remainder. So we've been doing that when we've been converting between different base number systems, different place value systems. And so here we do that division. 2400 goes in the 7100 2 times, and then what we actually care about here is the remainder. So 2300 is the answer to the question, doing it this way, and for whatever reason we didn't care what day we're meeting our contact, which is kind of important probably, but to just answer the question exactly what was being asked, it was 2300. So that means 11 p.m. You can just take 1200, subtract it from 2300 to get that 1100 hours means 11 p.m. So this was a much shorter way to do this. We can do this for when we have many, many cycles of 2400 hours represented. And just kind of showing this formula, how the formula is working. The present military time is like in blue, taking where all the hours from up what we have to our starting point, and then we take our total hours that we want to add, or the 50, put it in the right scale by multiplying by 100, and so then we just add those up. So what is the total number of hours starting from that day? So where we are in that cycle of 2400, and then, you know, how many more hours do we got to go? Take out the 24-hour periods, and then that puts you at 2300 hours, which is where you would be in that particular day. So that's how we're going to do this, is with the formulas. Just a word that these formulas, when we do this cycle math or modular math, there are tons of ways you could put together these formulas. And so I decided I wouldn't expect that you put together the formulas on your own. You can just use the ones on the formula sheet. But it's not like a unique formula, that this is the formula you have to use to get the answer with that cycle math. There's like a lot of different formulas you could come up with that are right. So this is just one of many. Let's actually work out an example now in the style in which you would want to do it. Let's say right now it's 9:05 military time. What time is it 128 hours from now? So just looking at the formula on the formula sheet, which you'll have on your test, future military time is the present military time plus the number of hours times 100. That's in brackets mod 2400. So for short, FMT is equal to brackets. Our present military time is 9:05 plus the number of hours is 128, times that by 100, mod 2400. Now there's some fancy modular algebra you can do, but for our purposes, the thing that will always work, and we should just kind of do it this way, is to do the parentheses first, find the value out front of the mod part, and then just do that mod part at the end. So within those brackets, what we have is we do multiplication first, right, with order of operations. So here we get 12 with the 8, 2 zeros, so 12,800. We're going to add the 9:05 to it. So doing that, we get 13,705. Take that mod 2400. So what this mod 2400, just get used to this, what that means is where are you in the cycle, the first cycle of 2400, or you can kind of think of that. Like in one cycle 2400, if you're just trying to take out the cycles of 2400, where are you in that cycle when you have 13,705? So the answer is going to be when you take 2400 into 13,705 with long division. So again, you can use a calculator here and take 13,705 divided by 2400 to get the whole part if you want, but then ignore the decimal. Just take 5 times 2400. We get 100 or 1200 or 12,000, excuse me. Subtract that, we get 1,705, and that's our answer, the remainder. We don't care how many cycles we went through for this application or for modular arithmetic. We just care where we are in that cycle of 2400, where we end up. So the answer here, usually we don't put a comma, is 1,700 hours, 1,705 hours or something like that. And that's it. So just practice for a second. What is this in PM time? Because this number is greater than 1,200. So what? Yeah, you just subtract the 1,200, or 17 minus 12, and then what you get is 5. 5:05, and then you insert the colon there. So just an aside that means 5:05 p.m. So questions on that one? So you have a formula, and you can just use that if you prefer, which I would suggest. You could be creative and come up with your own formula, but you know, you have this one at your disposal. Let's backtrack and look at the assignment. On the first page, you have a bunch of just modular problems to do, modular arithmetic problems. And so this is going to help you with that. I just want to go over sort of a motivating example to kind of see like why we're even doing this. And hopefully it'll make more sense and you can think about this idea of taking out the cycles with something that's more familiar. So now we have 4 plus 10 in parentheses mod 11. So kind of like on that example we just did, just think of doing PEMDAS or order of operations and do parentheses first. So you get 14. When you do that addition, mod 11. I don't really need the parentheses, so 14 mod 11. And think about this as, where are you in a cycle of 11 when you're at 14? You can just think of this all the time, you know, as what that mod 11 means. Where are you in the cycle of 11 for the number that comes first, 14? And so you could probably just do this in your head, or do long division, and that'll be the result with the remainder. So 11 goes into 14 once, so that means there's one cycle 11 in there. We want to know where we are in the cycle of 11, or in other words, finish the division problem, find the remainder, and that's the result. So we're 3 hours along, or I'm using hours again, this could be something else, but what I'm getting at is the result is the remainder, which is 3. So let's backtrack in this problem and just, I'll give you a little rule here. If this first number is greater than or equal to the modulus, or the second number, just call it that, this thing, then the answer is the remainder after doing long division. So questions on that one? We're going to do a couple more. This next one, what do we do first? Same thing we did first on the last one. So do parentheses first. You can just think of it that way. And what do you get out front? What's 1 plus 3? It's 4, right? So let's think of this as, where are we in the cycle of 10 when we're at 4? Anybody have that? Or want to put yourself out there? It's actually really easy. You don't have to do any work. So this would be similar to saying something like, well, if we're at 5 o'clock, where are we on the clock between, you know, our clock and, let's say it's 5 a.m. and we're, where are we in the cycle of 12 hours for the first part of the day? Well, we're at 5, right? We've gone 5 hours along at 5 a.m. So what is 4 mod 10? Where is 4 in the cycle of 10? 4. That's it. It's just itself. So this is the first time we've seen this. And the rule is if that first number is